Thank you, everyone. Today we will present a concrete example of a circular economy project. This project aims to optimize the organic waste collection and transportation supply chain in a rural area in Quebec, Canada. Before to jump in, I would like to present myself. I am Othman Dayi, the scientific director at Innovlog, and today I am accompanied with my colleague Ahmed Ben Ahmed, who is a logistics analyst at Innovlog. So the plan of our presentation today will be as follows. We will begin with a brief introduction to our company. Then we will explain the project context to you. Next, we will discuss the strategy adopted to solve this challenge. And finally, we will share our experience of using anyLogistix. To start by who are we? Innovlog stands for the Quebec Institute for Innovation in Logistics. We are a research and technology transfer center based in Montreal, Canada. We are the only college center for technology transfer who is specialized in logistics here in Quebec. Also, our mission is to help the Canadian companies to increase their logistics performance. So we are a non-profit organization affiliated to the College of André Laurando here in Montreal. At Innovlog, we cover the entire supply chain management, starting from procurement to production, warehousing, and distribution. We have carried out multiple projects, which can be like data analysis, warehousing and distribution center management, supply chain optimization, or network design and transportation optimization, which is the focus of our presentation of today. So we will provide you with a comprehensive illustration of a real case of vehicle routing optimization for valorize. Valorize, it's a company specialized in the collection and recovery of organic waste. To start, as you may know, organic waste represents one of the main sources of waste in Canada, accounting for over 58% of the annual quantity produced. This is equivalent to 35 million tons of lost waste each year. And this is equivalent also to a market of $48 billion, which is waste each year. In addition to these losses, food waste also results in the emission of approximately 56 million tons of CO2 into atmosphere. So it becomes essential to rethink the way we manage this organic waste. One of the models capable of addressing this recycling need is the circular economy, which aims to minimize waste by promoting reuse and recycling, and the generation of resources to create a sustainable and regenerative system. The circular economy offers numerous benefits for businesses. First of all, it reduces waste and pollution, and this will conserve the natural resources and reduces the greenhouse gas emissions. It also supports economic growth and fosters innovations. And finally, it creates opportunities for social and environmental value creation. On the other hand, the collection of organic waste faces many constraints. First of all, it involves multiple stakeholders, such as waste generators, collection companies, processing facilities, which requires coordination between all these actors of the value chain to ensure efficient and effective operations. It also requires specialized equipment, such as collection vehicles, containers, which can be also costly and to acquire and maintain. On the other hand, the organic waste is highly perishable and can decay quickly. As you may know, here in Canada, in winter, we have harsh winters, so we cannot, for example, keep a recycling bin outdoors. And also in the summer, we cannot keep the recycling bin for a long period because it smells bad. So there is some external factors that we should take care of. Also, like there is other factors such as traffic congestion, access to collection points, which should take into consideration. So the objective of this project is to act on the collection of organic waste in order to optimize the logistics operations by reducing operational costs and also reducing the environmental impact. So for the business challenge that we solved, first of all, our challenge was to define the optimal sequence to be made by each vehicle. So that's include the order in which visits should be made, the scheduled time for each visit, and the vehicle to allocate for each visit. All these objectives should be should minimize the CO2 emissions and minimizing the logistics costs and increasing the efficiency of the collection operations. To do so, we implemented a methodology to solve this problem. This is a 5-step methodology. First of all, we define the problem. So it is necessary to clearly define the problem by identifying the main challenges related to the collection of organic waste and understanding the specific needs for the local context. So for this, we visited each actor of the value chain to understand what are the constraints that he faces. After that, valorize gave us like some databases for example, each of the collection points, but we also did a survey to collect more data from each actor of the value chain. Next, we formulated the model and we choose a solution method adapted to the modelization. And finally, we implemented the solution and validated with each actor. So once we had the solution, we validated with the valorize and then with the actors of the value chain to ensure that the solution is compatible with all the constraints that we had at the beginning. So I will let my colleague Ahmed explain why we choose anyLogistix to answer this problem.
So, thank you, Atman. In this let's continue. This section aims to demonstrate the choice of anyLogistix to respond to our customers' requirement and to share with you our experience with anyLogistix. So why we choose anyLogistix for this specific issue? To answer this question, it's essential to examine the link between the functionalities offered by this tool and the specific issue highlighted. This project, as Atman said, aims to optimize vehicle routes for a company specializing in the collection and valorization of organic waste, with the goal of reducing operational costs and greenhouse gas emissions. For modeling purposes, the collected waste will be considered as periodic demand to be fulfilled from a single distribution center with a fleet specialized truck. So on the other hand, we have to make sure that all assumptions considered in our project could be satisfied by anyLogistix or others way to solve the problem. These assumptions are as follows. There is only one type of waste collection vehicle with limited capacity. The location of the depot and each waste bin are known. Each collection point has its independent rate of waste generation. All waste collection vehicle must return to the depot when collection tasks completed. Each waste bin is only collected by one vehicle once. So for that, let's consider the mathematical formulation that translates the problem to be solved in this project. Our objective, or the objective of our model, is aims to minimize both the transportation costs between different collection sites and the emission associated with this activity. This objective involves visiting some constraints, such as visiting each site only once, starting and ending each route from and to the depot, ensuring that the transported quantity does not exceed the capacity of the used vehicle and that the route length does not exceed a certain fixed length. Additionally of that, subtowers are not allowed. What means we can't visit A, B, C, and return to A another time. Based on our expertise on this field of transportation optimization and our previous experience, after analyzing the complexity of our instance, we concluded that it is possible to adapt an exact approach and solve this model optimally. Therefore, two approaches are to be considered: anyLogistix or Cplex through programming in Python or any other suitable language like C++ or Java. Each approach has its own characteristics. For example, anyLogistix is a powerful software that uses advanced algorithms and to optimize logistics operations. It's user-friendly and easy to integrate with existing systems. And it allows saving, modeling, and method selection steps. On the other hand, programming offers more flexibility and allows for more customization, but requires solid background in coding and mathematical modeling. Using anyLogistix would allow us to save a considerable amount of time while ensuring the quality and optimality of the solution to be proposed to our customer. Hence, the final choice is based on anyLogistix taking advantage of its transportation optimization functionality. So for the rest of our of this section, we will only focus on anyLogistix, and we will share with you our experience of using the two solution proposed by anyLogistix. But we would like to remind you that in addition to its ability to offer an advanced optimization tool for solving a vehicle routing problem, anyLogistix also offers the following advantages, like greenfield analysis, supply chain network optimization, and the supply chain simulation. But the option we are most interested in our project is transport optimization. And to improve this option, we are going to separate it into 3 different steps. Let's start by the first step, which importing data following the anyLogistix model. In this step, we focus on the different data tables used in this case study and on the methods for entering these tables with the data. Once all data has been loaded into anyLogistix, the next step is to run our capacitated TU experiment to solve our vehicle routing problem under study. And finally, all that remains is to visualize and analyze the result obtained. What makes this experience more enjoyable for users are the features implemented by anyLogistix. And as you can see, with a user-friendly interface and a simplified method, anyLogistix, for example, lets you upload data in 2 different ways. The first one is to load the database, like Excel files for this case. This approach is recommended when the quantity of data is large and it's easier to obtain it on Excel. However, you will need to make sure that a certain structure is followed so that the information you input can be properly interpreted by anyLogistix. I'm gonna share with you a quick tip that allows you to have a template that you just need to fill it. This template, you can obtain it by right-clicking on the scenario name and downloading it in Excel format. So the other approach is to simply use the visual display available on the user to enter all the information in a simplified way by scrolling throughout the different tables proposed. For our case or for a specific scenario, we use it exactly 13 from data tables proposed to set up all the data required to run our experiment. We specified all the collection points as customers, which we then sorted by city. For each collection point, we specified its location and the quantity to be collected, introduced as periodic demand to be satisfied, and finally its work schedule. Our collection center is modeled as a distribution center, a DC, with a fleet of 10 specialized 5-ton trucks supplying a product the unique product is organic waste. And finally, we have introduced the various potential route paths to be followed and the processing time for each depending on the product and the collection point. So now we are ready to perform our two experiment. In other words, solving a capacitated vehicle routing problem with time window on anyLogistix. It involves 4 steps. The first one is set up the experiment to be launched. Secondly, we impose or not a constraint on the use of time window. After that, we have to set solver parameters and finally run our experiment. So for our case, the instant what we use consists of one distribution center, 42 pickup sites, periodic request over a 7-day period, 10 specialized 5-ton track, collect is possible between 8 a.m. to 5 p.m., DC opening hours from 6 a.m. to 7 p.m. A processing time of 15 minutes should be taken into consideration. For this example or this instance, the company needs to perform 5 routes per week for a total cost of $121. You can see the start and time for each route as is follow. The view below will show you the optimal routes to be taken to collect all the organic waste while minimizing transport costs and CO2 emissions in total conformity of the constraints of our problem. But in addition of this view, several other views are available in tabular form for more detailed results concerning the route segments obtained and their associated costs. So we consider that working with anyLogistix was beneficial on several levels. First of all, by implementing anyLogistix, the waste management company was able to achieve significant tangible benefits. They were able to reduce their transportation costs and improve their operational efficiency. This resulted in a substantial increase in their profit margins. Additionally, the use of anyLogistix helped the company to reduce their carbon footprint by optimizing their transportation routes, by reducing unnecessary emission. This helped them to meet their sustainability goals and improve their reputation in the market. More of benefits, like intangible benefits, the result of our approach demonstrate a company's commitment to CSR. It shows the responsible business practices and portrays the organization as environmentally conscious and concerned about its impact on the community. Adopting such eco-friendly practices enhances the company's public image. Consumers and stakeholders are increasingly interested in supporting environmentally responsible business. By optimizing routes, reducing fuel consumption, and implement efficiency practice, companies can lower operational costs, maintenance expense, and fuel expenditure, ultimately improving their financial performance. So, as a summary, this project focuses on optimizing vehicle routes for waste collection and valorization company. The goal was to reduce operational costs and greenhouse gas emission. The waste is treated as a periodic demand collected from a single distribution center by a specialized truck, and we use anyLogistix to optimize the collection process in our case. Thank you, everyone.
So in the chat box, there is a question there waiting for you if you can see it.
To answer the first question, the question was, you mentioned limited time available for waste collection in summer. How did you implement this constraint in your model? So for this model, we did not make difference between summer and winter, but we are working now to integrate the seasonality in our model. The second question from Andre, on a scale from 1 to 5, how would you rate anyLogistix software as a software for your project? We'll let you answer.
I will say, in professional world, it takes 5, because it's really easy to put our data and run a TU experiment as quickly as possible. So you can give answer quickly to your customer, and it's essential in our field.
The third question is, do you use dynamic simulation to address this problem, or is just capacitated TO?
No, it's only a capacitated TO. We don't need to use the dynamic simulation, and as we can see, our instance is not as much big, so we can solve the problem to optimality and get the best solution with a simple capacitated TO.
And also what we did is we did like we variate like the time to visit, and we see that the solution didn't change even if we change like the time to visit each of colleagues' points. There is also a question from Jonathan. ALX 3.0 does not include the TO module. Why? I cannot answer that because we use the prior version of anyLogistix to solve this problem.
I think that question about ALX 3, it's a question that our support team will write in the chat and answer that. There was a question previously up above about wouldn't you have to invest more in CAPEX if you limit the transportation to just one lane and customer?
I didn't understand the question. Maybe if you can give us more clarification.
So we'll have to hope that he'll be quick in giving clarification. But there are new questions in the Q&A you could answer while waiting.
Yes, sure.
Is there any issues with anyLogistix that you're facing during your project? No, it was like we discussed before. It's a really user-friendly tools, so we didn't find any issues with using it. So it was easy.
The other question from Gleb, I think that dynamic simulation could be a good idea to try to address the limited shelf life for collection. You could set the expected lead time and analyze the ETL I think service level for the collection point. Okay.
Yes, but we have to go to collect the information about the.
Can I get the full case study with data? We don't have like the right to share like the data, the company data. We can give you like say a quick overview of the projects, but we cannot give you access to the real data.
There is one more question in the chat. Looks like people are getting chat, question, answer, chat, question, answer. So you have to jump back and forth, but you can see there's one there.
Yeah, this is a question from Lam. If you build the constraint to limit the transportation mode, would you have to invest in more trucks? We unfortunately we didn't have like this flexibility to choose the trucks. We use like the trucks that the company owned at this moment, and we designed the network and optimize the transportation.
As a result, the company have 10 trucks, but when optimizing, we need only 5 of these 10 trucks. So I don't think investing in buying new trucks are for our company are useful, because it costs a lot of money for these specific trucks.